Welcome to the ftir.fun Infrared Learning Series. This episode, Ep30 Coatings and Inks, Composition Analysis and Quality Control, and close with the checklist. Next, a Ripping Automotive Paint. In 2023, a car manufacturer's painting workshop experienced batch quality issues. The clearcoat exhibited ripping, sagging after baking with poor adhesion and gloss. A on-day production halt cost 500,000 Chinese yuan. The QC team sampled defective and normal paint films, performed comparative analysis using a tristor. The defective film's spectrum showed significantly weaker bands at 1,240 cm, ether CoC, and 830 cm, epoxy characteristic. While the 1,735 cm, ester C equals O, band was normal, indicating insufficient TOS-A curing agent ratio, leading to inadequate cross-linking. Next, coating resin binder identification. 1.1 Infrared characteristics of main resin binders. Coating binder is the core component determining coating performance application. Next, infrared characteristics of pigments and fillers. 2.1 Characteristics of inorganic pigments, fillers. Common inorganic pigments and fillers used in coatings, inks, have characteristic absorptions in the low wave number region. Next, headspace detection of solvent residues. 3.1 Hazards of solvent residues. Residual solvents after coating ink application, ftir. Coating performance, hardness, adhesion, environmental safety, bulk emissions, food packaging safety, migration into food. Next, in situ ultra-anterior monitoring of coating curing process. 4.1 Principle of in situ monitoring. H2 in situ monitoring involves applying liquid coating onto an crystal, collecting spectra in real time to track the curing reaction isolation. Next, ink component analysis. 5.1 Basic composition of ink. Ink is similar to coatings, but the formulation is more refined. Next, case study. Troubleshooting coating defects. After spraying polyester powder coating on refrigerator door panels produced by a home appliance factory, some batches showed unqualified coating adhesion, crosscut, test peeling, while other batches were normal. Sampling Ep30 sample coating with unqualified adhesion. Control sample coating from qualified batch substrate. Both batches are galvanized steel sheets. Next, practical experience. 7.1 Sample preparation tips. Liquid coatings IDS drop directly onto crystal or coat on paper EQL for transmission measurement notes. Measure after solvent evaporation. Avoid solvent interference. Next, review questions. An unknown coating spectrum shows strong absorptions at 1,240, 830, 3,040 cm, and no peak at 915 cm. Infer the binder type and curing state. Finally, the drill actualists. Make sure you can recall each item. Core knowledge point. Key points. Bulky resin. 1,730. Ester C equals O. 740 ortho substitution. 1,600, 1,580 aromatic ring. Epoxy resin. 1,240 aryl ether. 830 para substitution. 915 epoxy group. Disappears upon curing. Polyurethane. 3,350 NH. 1,720 amide I. 1,530 amide Ch. 2,270 and coal. Disappears upon curing. Liquidity resin. 1,735 ester C equals O. 1,160 CoC. No aromatic ring. PO 800 500 cm broad. PO SO 1,190 1,120 1,080 cm. So, HACO 1,420 875 712 cm. Coal. Headspace detection of residual solvents. Long path gas cell. Epoxy curing monitoring. 915 cm decreases during degree calculation. Pool curing monitoring. 2,270 centimeters, and code disappears. UV curing monitoring, 810 1635 cm equals C decreases. Offset printing ink, rosin phenolic plus alky binder, gravure printing ink, polyamide or nitrocellulose binder, UV ink, acrylate, 810 centimeters characteristic. Defect analysis, good, bad comparison. Locate differential peaks. That covers the required stencil for this episode. Practice with real spectra on ftir.fun and continue with the next lesson.